Hello guys, welcome to another section of Math. Today in this video, we'll be looking at how to differentiate this whole question here. As you can see, there are lots involved. There's not all that lot, but this question here requires a lot of workings to get your answer. The answer is just a single thing, very simple, but to get it from the derivative of the whole of this is not all that easy. So we are going to go through a lot. We are going to do a lot of workings to get our final answer. But this question here is actually an answer to one of the integrals we solved in my previous video, which is integral x multiplied by tangent inverse of square root of x. That is when this 2 is not there, x multiplied by tangent inverse of what? Square root of x dx. Now, in that previous video, we integrated that particular problem, and then this whole thing here is the answer that we had to that particular problem. And remember, in that video, I said that, well, we are going to try differentiating this whole answer to find out if we can get x multiplied by tangent inverse of square root of x, if you can get that particular question back. So as I said, as you can see, there are a lot about 1 2 3 4. There are a lot about 4. Yeah, it's 4. So it won't be all that easy. If you look at this one, tangent inverse plus x squared, and it's a fraction. This one too, tangent inverse is a fraction. This one, okay, this one's a little bit simple. This one is square root of x, bracket close, raised to the power 3, and it's being divided by 6. It won't be all that easy for us, but whether it's going to be easy or not, we are going to do it. Okay? Yeah, that is the morale. That is the can do spirit. Yeah, just believe in yourself that you can do it. Okay? So what I'm saying, what I'm telling you is, since we are going to do it, I will entreat all of you to get your pens, your minds, everything set ready for what? The journey, because there is going to be a lot of what? Algebraic manipulation. We are going to do a lot of what? Computation after the derivative of each of them. I've already told you, if you don't do the computation, you will not get your final answer. Okay, so guys, without wasting much time and with everything being set, let's start our journey of differentiating this whole answer here. Okay, so first let's write our solution. Okay, now as usual, yeah, remember in my the other previous video, or in the other video, I said will not be setting this y equal to this one equal to, but because there are lots involved, and this one is about 4, and then the kind of to break it down, make it more simple for us to understand, I'm going to bring that one back here again so that we can follow it very easily. Okay, yeah, wherever I messed up, I will do that explanation with my mouth, and wherever I messed up, that part, you are already conversant with that part. So if you see that particular step is mixing the solution, you could see that the moment I hammer it or talk about it, you could see that, oh, I already know. Okay, so first let's set y is equal to the whole of this problem that we are differentiating. Like I said, it's gonna take us a little bit long, but don't just get confused, don't just get bored. you just take your time, your calculus, everything ready, and just follow. And then I believe you will never get bored, because this whole thing here is just going to be fun, because in the land of mathematics, everything is what? Fun. Okay. Okay, that was just by the way. Let's continue. Now let's write our equation. Yeah, it's very long, so if I don't read them, don't worry. But I'll be reading them. I'll be reading them. Just that this part we are all used to. Okay, so y is equal to, as I said, I'll be reading. Okay, so y is equal to x squared tangent inverse of square root of x minus tangent inverse of square root of x divided by 2, and this one also divided by 2, plus square root of x divided by 2 minus into bracket square root of x raised to the power 3 divided by 6. Okay, as I said, there are a lot involved. You know, we can't differentiate this whole thing at once. So what are we gonna do? What do you think? Yeah, I know what you are thinking, and I like what you are thinking. Separation, splitting. I heard the other guy saying we are going to split as usual. Yeah, that's it. Well, it's not forced to split. If you think you can solve it directly from here, nobody will force you. I always split them to make it very simple for us. Okay, so let's split them, or let's separate them and differentiate them separately, and then after that we just put our answers together. But we are going to do that in what? Bit. Okay, bit by bit, because the working here, if you don't take care, it might confuse you. Okay, so we are going to call this one A, B, C, and then D. This one we have gotten how many? 4. That is A, B, C, and D. And you remember the other time I said that sometimes, to be on the safer side, you have to forget the operation sign involved, and take the assume it's positive, or take it as positive, work on it. Whatever you get, you just put it back into the original equation, and where you have to expand, you just expand, and then you are good to go. Yeah, but the other time too, I think in my one of my previous videos I just uploaded, I said that, well, next time I'm going to be taking it along. We have we have solve problems without including the signs along, without including the signs attached to them. I mean, we have solved a lot about that. So here I'm going to take the sign along with it, and then I will show you how to handle it. Whether it will give us problem or not, I'm just going to take it along, so that if you wish in your solution to take that negative sign along, well, then you know how to handle it. Okay, you don't worry. So here I'll be taking them along. Okay, so when we are computing, we just pick whatever we get at the end of the day, we just put it there. In the original equation, we just put whatever we had there, positive or negative, we just put it there without considering any sign, because whatever we are going to get at the end of the day, whether it is positive or negative, the reference will what? Tell, not the original equation. Okay, so I'll be carrying the negative sign, or the sign written separating them what along. So this one I'll carry the negative sign along with it. This one is already positive, so no problem. This one too, I'll carry it along with it. Okay, and then you see how um, you are going to handle it. So without wasting much time, let's start with our first what journey. That is our first work. It is our first what work that we are going to do. That is what A. So let's start with A. We are going to differentiate what A. Okay, so let's start with that one. So differentiation of A, we are gonna set K is equal to A. And what is A? A is 1 over 2 multiplied by x squared times tangent inverse of what? Square root of what? X. Yeah, here as usual the product rule will work. You maintain this, you differentiate this, and then you maintain this, you differentiate this. Yeah, but what about this? Because this one is carrying us, or might nest some fear in us or mind, put our mind into confusion of how to differentiate this and this at the same time. Let's first take this one away, differentiate it separately, and then later on we come back to this original equation. After it has become simple, then we differentiate. Okay, so you're going to do substitution. You're going to let u be equal to square root of what? X square root of x, square root of what? X. Okay, so here, in many of my videos or in the other time, I said that when you get here, like maybe since we are moving on to the u world, everything has to be in the u world. But here, I'm not going to square both sides. Sometimes maybe you square both sides and then you get ds, and then you differentiate, and then you know what is going to replace what? Ds. But here in this case, we will rather after the substitution, we rather be looking for what is going to replace the u. So there's no need for us, finding dx. So here I'm just going to maintain this one, and maintaining this one can be of very important notice to us, or can serve us good, or can do us good, because most of the times we just square both sides and then we differentiate and we get ds, which is simple. But here I'm just going to maintain it and then I'll differentiate. Okay, as I said, it might take us a little bit long, but you don't worry. The most important thing at the end of the day is to get our answer, and also for you to what? Get your understanding. Okay, so just take your time, follow it. Where you have questions, draw attention, and then we answered you, and then we move on. Okay, good. So u is equal to square root of what? X. Now we are going to differentiate. So du will give us what? Du will give us what? 1 over 2 multiplied by square root of what? X dx. Now, how did we got this answer? You already know from the laws of indices. This one, to differentiate this one, we have to write it in the form of what? A power and a base. The base is already what? X. The value of this square root sign is what? Half. So to differentiate it, we just bring the exponents down there, down, and then it multiply this what? X here. So that's going to give us 1 over 2 times x, and then we decrease the power by 1. So 1 over 2 minus 1 will give us what? That will give us minus half. And from the laws of indices, a raised to the power minus 1 can be written as what? 1 over a. 1 over a. So s raised to the power minus half can be written as what? 1 over s raised to the power half. And as usual, square root of x can be written as s raised to the power half. So s raised to the power half can be written as well square root of x. So by that, we are going to get 1 over 2 multiplied by 1 over square root of x. And when you multiply, this is what you are going to get. Okay, so 1 du is equal to 1 over 2 times square root of x, and then well, this is our dx. Here, because this original equation will be in the u world, there is no need for us to find what? Dx. Okay, so we're rather looking for what? Du. So after differentiating the original equation in the u world, we will replace the u with what? This one. Okay, good. Remember the other time I said that when you make substitution, everything has to be in the what? The new variable world. Okay, unless we want to treat the leftover of what? The first variable as constant. If you don't want to treat this x squared as constant here, what we have to do to find something that will what? Replace it. Okay, good. So to get what is going to replace x squared in the u world, we are going to what? Square both sides from this one. I didn't square it directly from here because I was going to differentiate. I wanted to differentiate, use this one to show you the differentiation of what? This. After differentiating, this is what I had. So now that I differentiate this one directly, we have to find what is going to replace what? X squared. Okay, so this one here was to show you this part, that is why I didn't square both sides in the next step. Okay, so now yeah, we're going to square both sides to know what is going to replace what. um um X, what is going to replace x squared. In yours, when you are solving yours, you can do that, and then you differentiate with respect to u, and then you get ds, and later on divide both sides by what. You can do it that way, but I wanted to show you that even with something like this, we can still what differentiate in the you can still what differentiate. Okay, that is why I didn't do it from this side, but rather from what this side. Okay, so u squared is equal to x. Now when you square both sides, u squared is equal to what? X. So in the u world, the remainings are what? After the substitution is what remaining. Since we don't want to treat this one as constant, x squared or x, the x squared can be written as bracket open x bracket close raised to the power 2. So what is going to replace that? Sorry, we know that x is equal to u squared. So wherever we see x raised to the power 2, we're going to put this one what? There. Okay, so now that we know what is replacing this and that, so let's replace them and then let's continue. Good. Here it was x squared, and remember I said x squared can be written as x into bracket raised to the power what? 2. And the value for x is what? U squared. And u squared times 2. U squared raised to the power 2 give us what? 2 times 2. And that will give us what? U raised to the power what? 4. Okay, now I think it's very simple for us to differentiate because we know the derivative of this and that of this one as well. Okay, so here we just apply our product rule, but I will not show you the product rule because of um yeah, I'll not bother writing that product rule because um you know the most important thing is to know how the product rule works, and when you get to know how it works, there's no need showing u is equal to derivative of this multiply. No, 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 no. We're not going to do that unless you want to use that one for the whole thing, and then so here using the product rule, we are going to maintain one and then we differentiate the other, and then we maintain the other and then we differentiate what? One. So either we maintain this and then we differentiate this, or we maintain this and then we differentiate what? This one. Okay, so here we are going to maintain this one. I'm going to maintain, addition is commutative, so anyhow you do it, you're going to get the same answer. So we maintain this one here, we are going to differentiate this. So I think decay will be equal to 1 over 2 times 4 times 4. And then we decrease the power by 1, which will give us what? 3 times tangent inverse of what? U, plus, then we maintain this one, then we differentiate this. And when you do that, you're going to get 1 over 2 times u raised to the power 4 times 1. The derivative of this one will give us 1 over 1 plus what? U squared. Okay, so decay is equal to, yeah, as I said, this is what you're going to get. And then we maintain this and then we differentiate this one, and when you do that, this is what you are going to get. But make sure, please note that this du here is not only affecting this one. The du here tell us that we are done with the differentiation of for the whole of for this du here is like into bracket here and another bracket here. Du, this du here is affecting the whole of this. So when we are replacing it, make sure you don't get confused. I know why I'm saying that, because when it's here, you might think it's only affecting what? This one. Okay, so now here, let's see what we can do. These two will go here 2, so this one will cancel out. It will give us what? 2. And then when you come here, I think to give us what? u raised to the power 4 divided by 1 plus what? U squared du. So the k is equal to 2 u raised to the power 3 times tangent inverse of u plus u raised to the power 4 divided by, these two would multiply this, divided by 2 into bracket 1 plus what? U squared du. Okay, now we are done with the differentiation, and then we have to go back. This is the answer in the u world, but what is the answer in the original world where we came from? That is what? The x world. The x world, like X-Men. Yeah, the x world. So what are we gonna do? Yeah, we have to go back to the x world. By going back to the x world, we have to know what is going to replace the u and what is going to replace what? U. Okay, so going back to the x world, we know that u is equal to square root of x, and then du is equal to 1 over 2 square root of x dx. So this one here, we're going to replace it with this one, and then this u, we replace it with this one. Wherever we see u after differentiation, we're also going to replace it with what? This square root of what? X here. Okay, so let's replace them. Here, make sure you don't just get confused. Remember, I said initially that wherever I made some step, I know that with that part we are more familiar with it and we will not get confused. Good. Now, when we replace u with s, that is what we are going to get. Here, I'm gonna get I'll talk about it. Don't worry, I'll talk about it. Here to give us 2 times 2 into bracket square root of 3 bracket close raised to the power 3 times tangent inverse of square root of x plus, I'll talk about it, times, here it was used to raise to the power 4, so here it will be square root of s bracket close raised to the power 4 divided by 2 into bracket 1 plus into bracket square root of x raised to the power 2. You are seeing this 1 over 2 square 1 over 2 multiplied by square root of x here because of what? The du. Du was equal to 1 over 2 times square root of x dx. So here actually supposed to be the whole of this one, in one bracket times 1 over 2 square root 1 over 2 square root of x dx. That's what is supposed to be here. But when we do that, the next step, we are actually going to multiply that one through, when you do that, definitely you have to open the bracket by multiplying this one, which might have been here what? True. Okay, so let's say to go a little bit fast, I multiply it through directly. Okay, so I use it to open the bracket. As I said, it's the whole of this, and then this in one bracket times this one, and then what? That. But at the end of the course, at the end of the day, this one will eventually open the bracket and multiply it through. I just did this in the next step rather than what? Writing that one and then taking this one to what? The next step. And I know you know why. And I know you are okay with it, or you are familiar with that, just to save some hot time. Okay. All right. Yeah, that 1 over 2 square root of x will just multiply the whole thing. I told you that du is not affecting only where it is being attached, but the whole thing. Okay, so when I multiply to this, what you are going to get? You're going to get 1 over 2 square root of x multiplied by what? 2. Multiplied by the whole of this plus the same thing, 1 over 2 square root of x multiplied by the whole of what? This, or the x. Okay, good. I hope you are not lost and I hope you are not confused. And I believe you will never get confused. In yours, don't omit that step. Put this and then this into bracket and then multiply by 1 over 2 square root of x dx as it being equated to what du. Okay, and then in the next step you do it this way. You see, you're going to get the same answer as we are going to get in the next step here. All right, so here these two will cancel out with these two, and then here we are having square root of x raised to the power 3, and also we are having another square root of x here. So this one will decrease this power by what? 1. So here we'll be left with what? Here we'll be left with what? 2 is 3, and this one will take away one of this and to be left with what? 2, and that one will be what? Square root of x raised to the power 2. And then when you come here, the same thing apply here. Actually these two cannot cancel anything here, but let's look at the square root of x. Okay, it matches something here, square root of x, and then when you come here we're having square root of x raised to the power 4. The same things apply. This one will decrease this power by what? 1, and when it decreases this power by, we're gonna get what? Square root of x raised to the power what? 3, and then 2 times 2 will give us what? 4. Now when you come here, when you open the bracket, these two will take away the square root sign away, and inside here to be left with 1 plus what? X. 1 plus what? X. So the x over the k, as usual, you know why I'm writing this, because we are done with the differentiation for a, almost done. Okay, so after the cancellation, that is what we are going to get. As I said, square root of x raised to the power 2 times tangent inverse of square root of x plus square root of x raised to the power 3 divided by 4 into bracket 1 plus what? X. Okay, so here let's look at this side. This 2 here, this square root sign will cancel out with these 2 and it will be left with what? X. And then when you come here, this one, when you open it, it can be written as square root of x times square root of x raised to the power 2, and that will give us x square root of what? X. Okay, this one is 3. We can write it in, we can split it into 2, that is 1 and then 2. We just pick 1 and then we will leave the rest in this form, of which this and that will go away and it will be left with x, and that will give us x times square root of what? X, which at the end of the day, when you simplify in the form of indices, you are still going to get this one back. Okay, so dk over dx is equal to x multiplied by tangent inverse of square root of x plus, as I said, this one here can be written as x multiplied by square root of x divided by 4 into bracket 1 plus what? X. When you reach here, please don't bother open the bracket. Don't open the bracket. Don't multiply it, because if when you do, when you are doing computation at the end of your final answer, or to get your final answer, you will still have to factor it out. So just leave it there, because you don't know, maybe other parts of the workings, other workings that you are going to do, you might get something which will look like this, which at the end of the day can what? Cancel out, or yeah, which can cancel out. Because so when you open the bracket and then you get something which looks like that, and to cancel out you have to go rewrite, you now have to factor it out again before maybe you do your cancellation. Who knows? So just leave it as it is. So this is the okay, this is the answer to the A part, but I think let's make it a single fraction. Let's write it as a single fraction. let's write it as a single fraction. So to write it as a single fraction, the LCM, the LCM is what? This one. So we just multiply this one by the whole of what? This. And then we add this one. So when you do that, this is what you're going to get. You're going to get this one multiplied by the whole of this to give us 4x into bracket. I said don't bother multiplying it through. Okay. So 4x into bracket 1 plus what? X. Bracket close, multiply by tangent inverse of square root of what? X, plus x square root of what? X. When we give it one LCM, multiply this by that, and then we add this one. This is what we are going to get. So that is the answer to the A part. The answer is just this one or this one. This one is a simplified version of 4. Let's say this one. Okay, just write it in the form of a single fraction. So let's move on to the other one. So differentiation of b, we are moving on to b. Differentiation of b. Okay, so let's write b. Yeah, I said I'm carrying the negative sign along. Okay, so make sure you don't get confused. Well, carrying it along maybe here might not give us any problem. Maybe this problem here that we are solving, carrying it along might not give you any problem at all. But maybe, well, maybe a problem that maybe you one day encounter maybe can be giving you that this a lot of negative sign where you get negative plus your original negative, something like that. And yeah, I've been there before. I know what it's like. So this one will not actually confuse us or give us any problem. It will just be that till the end of the differentiation of what? B. Okay, so as usual, here we have to just differentiate this one. We just maintain this one and then just focus on this. But this one, well, I'm just going to show you this one the second time. Okay, so substitution, we will let m be equal to square root of what? X. Maybe the other part you didn't get it, but maybe here you're gonna get it. So m is equal to square root of what? X. We are going to differentiate as we did in the other section. So to differentiate this one, you just write it in the form of power in a base, and then you multiply the power by the base, and then you decrease the power by 1. And when we do that, you're going to get dm is equal to 1 over 2 square root of what? X multiplied by dx. Okay, multiplied by dx, and we will not bother finding dx, and you already know why. I've already talked about it in the other section. So here I'm just going to carry on. Okay, so let's put m here and differentiate this original equation. Okay, you see the negative is not giving us any problem. It's just there till the very end. Okay, z equal to minus 1 over 2 tangent inverse of m. This one is simple. This one we easily know the answer to the tangent inverse of what m. And if you already done some in the other part, I would have omit this one and write the answer directly for you, but I consider that the other part maybe some of us will just get confused. But here, because it's very simple, the only thing here is what? Tangent inverse. Maybe let me bring it, ponder on it or hammer on it. Maybe somebody who get lost on the first part maybe can get found in this this section 2. Okay, or can get found in this section. Okay, so now let's differentiate. Now to differentiate this one, you already know the answer to this one. Okay, you already know the answer to this one. That is to differentiate. When you differentiate tangent inverse of m, you're gonna get 1 over 1 plus m squared, 1 plus m squared, or m squared plus 1. Anyhow you write it, addition is what? Commutative, but make sure you multiply it by this minus half here. It's not half but minus half. It's not half but what? Minus half. Okay, so dz is equal to yeah, minus 1 over 2 into bracket 1 plus m squared dm. We are done with the differentiation. We have to go back to the x world. That is the answer in the m world. What is the answer in the x world? Well, let's find out. We know that m is equal to square root of x and dm is equal to 1 over 2 root x dx. So here you put this one there, and then here you put what? This one there. So let's put them. Good, and you know why this one is here. It's because of what? This. Definitely it will multiply. So I did it straightforward. Okay, so dz is equal to 1 over 2 root x times minus 1. You can even choose to bring the minus here or maybe here, or to be on the safer side, just leave it here as it is right now. 1 over 2 into bracket 1 plus square root of x raised to the power 2 dx. Now here, these two will cancel out with this and to be left with x, and then 2 by this one will give us what? 4, and then the square root also here. So we're gonna get dx over dz over ds will be equal to minus 1 over 4 root x into bracket 1 plus what? X. Okay, here, with math, solving problems in math requires application of what? Other areas. You don't just learn this area and think that every problem that you encounter in math will be of only this area. Sometimes you have to apply knowledge of about 2 or 3 areas just to solve one particular problem. When we were differentiating, we apply indices to differentiate, and maybe, yeah, we apply what? Indices, but here we are doing what? Differentiation. What does indices got to do with differentiation? Sometimes you have to apply to help you what? Solve your problem. If you don't apply it, you will never going to get your answer. So here, what we are going to do here, we're just going to recall other areas in math: radicals or said. And what am I referring to? What am I trying to draw attention to? Rationalization. Rationalization, that is rationalizing of what? Denominator. Here, 1 over, don't forget it's negative, 1 over 4 root x into bracket 1 plus x. When we leave it like this, well, no matter what, at the end of the day, in our final answer, maybe, who knows, we might not get anything that will look like this. So maybe, to be on the safer side, let's rationalize it. And to rationalize this answer, we are going to multiply the numerator and denominator by square root of x. Square root of x, not the whole thing. What we want to take it, what the reason why we are doing rationalization is that we don't want the denominator to be in what? A form of what? Square root. We don't want any square root to be part of the what? The denominators. Okay, so we have to rationalize it, and by rationalize it, the denominator will no longer be what? Square root form. It will go off, and the numerator for the numerator, when it is in the form of square root, you can no problem with it. But your final answer in the form of, if the question doesn't stay so, and you have left your answer, or if you have leave your answer 1 over root 2, you might lose some marks. You have to rationalize it. Okay, so let's rationalize this one. We're going to multiply top and down by square root of what? X. Square root of what? X. Rationalizing the denominator. So rationalize the denominator. So let's rationalize. So dz over dx is equal to minus 1 over 4 square root of x into bracket 1 plus x times, that is how we rationalize. To take this one away, just multiply both top and down by the same thing. assuming if this side could have been. That is why I said don't bother opening the bracket, because when you open the bracket, rationalizing will no longer be of this form. It won't be of this form, but rather it will be what we call conjugate. You have to rationalize by using the conjugate of this one. Maybe when you open it, that is, this one will give us 4 root x plus 4x 4x root x, 4x root what x. So to rationalize that this denominator after it has been opened, you have to do so by it conjugate. That conjugate simply means you are to change the operation sign. To conjugate something means you have to multiply it by it what opposite. So if here is plus, conjugating it, you just use what the same thing but what minus, and to be like difference of two squares. That will give you what the denominator, and by that it will take it away. Okay, good. So here this times this will give us what root x all squared, and that will give us what x. And here we are going to get dz over dx equal to minus square root of x divided by 4x plus 4x into bracket 1 plus what x. You see, this one look nice than this one, or even this one. Yeah, if you open the bracket, you just escalate your problem. Yeah, and we don't want to do that, because even this one alone is giving us headache. We are rather fumbling. Okay, so it is the answer to, the negative sign didn't even give us any problem. Okay, but don't worry, maybe in our next problem we must encounter where the negative sign that we carry it along, is confusing us. There is going to be maybe a lot of negative sign involved in the operation, in the workings itself, together with what the original negative sign, where you have to, do negative pour, take this one, bring it, yeah, something like that. Don't worry, maybe you might encounter something like that in, who knows, one of these days you might encounter something like that. Okay, so let's continue. Okay, this is the answer to the derivative of what? B, the B part. Now let's move on to C. Okay, you're gonna set T is equal to C. See, there it was positive, so that is how here it is. We already know how to differentiate this, so this one I'm not going to waste time here. So the T is equal to, you already know how to do it, so you just watch the workings and you are good to go. I'll not waste time talking about it. So the T over dx will give us what? Okay, good. This is where I will do some talking. Here, rationalization. I said if you leave it like this, the other part, it was 4 root x 1 plus into bracket 1 plus x. It wasn't like this. Whereby maybe you have to, compare. Well, who knows? So this one too, let's rationalize it. To make it look good, simple. Okay, so how do you rationalize? Just take the square root, multiply both top and down by what? 8. Here will be 4 root x multiplied by root x, and this one to be 1 times what? Root x. So dt over dx equal to, now when we do that, we have done some in the you have done some, few minutes ago, so, or a few seconds ago, so I'm not repeating that. So I just write the answer straightforward. I said multiply this one by root x, then we multiply this whole thing by also root x, and when you do that, you get 4 times square root of x raised to the power 2, because the root x will be 2, and that 2 we write it as root x raised to the power 2, and that 2 will cancel out with this one, and to be left with what? X. So here I'm going to get 4x, and then here is what you're going to get. So dt over dx is equal to square root of x divided by 4x. Okay, so let's move on to the next one. Okay, so p is equal to minus 1 over 6 multiply by into bracket square root of x raised to the power 3. Okay, as usual, you already know how to differentiate this. Though it's square root by here, the 3 will still be a problem. We will still rewrite it in the form of a power and then a base. We will write it in the form of power and then a base. Okay, so when we write this one, the value for this one is what? Half. So it's going to be this 3 is already multiplying the power. So if we are already having a power here, that is 1 over 2. So 1 over 2 times 3 will give us what? 3 out of 2. 3 out of 2. And I've already told you to differentiate the power, we'll just come and multiply the base and then we decrease the power by 1. So this 3 over 2 will come and multiply this 1, which will give us minus 1 over 6 times 3 out of 2 times x raised to the power 3 out of 2 minus 1 minus 1. And 3 out of 2 minus 1 will give us what? 1 over 2. 1 over 2, because 2 times minus 1 will give us minus 2. 3 minus 2 give us what? 1. 1. And that reducing this one by 1 will give us what? Half. Half. So dp is equal to, so as I said, minus 1 over 6 times 3 over 2 times, we decrease the power of this one, but I've already demonstrated, or I've already show you how we decrease the power. That is why here I didn't show, that one we have done a lot about it. So here, this one will come down, that is here, and then we decrease the power by 1, that is 3 out of 2 minus 1 is going to give us what? Half here. So here, this one will cancel out with this one to give us what? 2. And then that is going to give us 1 over 4 times x raised to the power half dx. 1 over 4 times x raised to the power half dx. So dp over dx equal to minus square root of x over 4. And you know why? X raised to the power half can be also written as square root of what? X. Okay, guys, at here we are done with the derivative of the whole question that we are to differentiate. We are done differentiating them. We've gotten 4 different answers, and you could see that some of the answers are very long. Some of the answers are very long. As I said, it could take us a little bit longer. It will take us a little bit longer, but you don't get confused. You don't get bored. I hope you are not getting bored. Yeah. But still, though we are done with the derivative, but we haven't gotten our answer. So what are we going to do? After the differentiation, the next part is to do what? Computation. The next part is to do what? Computation. When I say computation, you have to do some addition, subtraction, dividing, multiplying, yeah, those stuff. That is what is left, because looking at the answers that we have gotten, there are a lot of them. Even one answer when we are to come, we can get about 2 or 3 different answers. So here we are going to add. When we add all of them, A, B, C, D, when we add all of them together, and then we are to take some away, do blah blah, it will confuse us. So what I'm going to do is that we are going to take answer for A, and then we take answer for B, then we put it together, then we simplify, then we move on to C, and then D. We put that one also together, then we simplify. When we do that, it will reduce the length of the answers, or it will reduce the numbers. When I say numbers, I mean the number of answers that we've got. Maybe A, we had about 2 different answers. Okay, so as I said, we are going to put A and B together, and then later on we put C and D together. And when we are done with them, we just write the answers we got to A plus B and then C plus B. We just put that one together. Doing that one after adding these two, A and B, and then C and D, that there we can take away some, we can add some, and that will reduce the number. So what will be left for us to put all together will be what? Very little as compared to adding the whole A, B, C, D together as what? One. That would be very, 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 it might confuse us, that would be very, very unsafe. Okay, so add A and B. So this is what I was talking about. And A and B, what is the answer that we got to A? We are representing it what? A derivative. So A is what? The derivative of we had dk over dx plus dz over what? Dx. This one is A, and then this one is what? B. And as I was saying, this whole thing here is answer to what? A. And then this whole thing here is answer to what? B. If you are to put all of them together, I don't think even we will get some space to write all of them. That would be very, very, very lengthy. This is the main reason why the answer to A part I decided to write as a single fraction here, just to save some space. If you don't do it that way, you get confused. Okay, yeah, it's very long, but don't worry, I'm gonna get at the end of the day. And I know when we get to say something like that. Yeah, sure. And I hope you are not getting bored. Don't just get bored. Math is full of fun. And you can only get bored when you cannot solve it. But when you know what you are doing, the confidence or the mood stays still to the very end. Okay, let's continue. Okay, so this one represents answer to A, and this one represents answer to what? This one represents answer to A, and this one to what? B. Okay, so this one here we are adding, but the answer we got to the B part was what? Negative. That is why the negative sign here. So it's rather plus minus, plus minus. So plus minus will give us what? Minus. Okay. All right. So this one plus this one, we are going to find what? LCM, LCM, LCM. So what is the LCM? Looking at this and this, what are you going to get? This and this, what are you going to get? We have this one here, this one is also here, 4 here, 4 here. So the only thing is what? X. Then we can pick this one as our what? LCM. When we do that, and then we divide this whole thing by this one to give us what? X. To give us what? X. And then we multiply the whole of this by what? That X. Okay, so let's write it down. Okay, dk over dx plus dz over dx is now equal to, I said the LCM is this one. So 4x into bracket 1 plus x divided by this one will give us what? X. And then you're going to multiply this whole thing by what? X. So remember, this one is 1. The whole of this one is what? 1. I said don't open the bracket. If you open the bracket, you are just multiplying your problem. Yes, multiply. The problem here is not all that easy, and here is the case you yourself want to multiply it up. It's your own, it's your own risk. Okay, so when we do that, this one will cancel out with this, and this, it will be left with x. And when you multiply this one by x and also this one by x, you're gonna get 4x squared into bracket 1 plus x multiplied by the tangent inverse of square root of x plus, this one also is attached, plus this 1 times s will give us what? This 1 times s will give us what? S squared square root of what? X. And then this divided by this or this divided by this will give us 1. So it will give us what? 1 times this will give us what? This. So minus square root of what? X. Okay, here looking at it, well, that is not the answer to this one. We can still reduce it. This work entails a lot. It entails a lot. So when you are watching, just take your time. Just take. That is why I said to take us a little bit long because it involves a lot. Okay. Here, 1 plus x and 4x squared. Here, x squared, square root of x minus square root of x being divided by this. Okay, here we can still reduce it. We can still simplify it. Okay, so here I'm going to simplify it. When you look at this side, we are having this one is x squared times square root of x minus what? Square root of x. So this one and then this one, we can factor it. So we are going to factor the square root out of only this and this. Okay, so we just bring the square root outside and we'll see what we are going to get. Okay, so dk over dx is now equal to, okay, so when we are doing that, you may just maintain this side. You just maintain this side. Okay, so when we factor out the square root sign, this is what we are going to get. When the square root sign come out, we're going to get x squared minus 1. Hey, you see what I've been telling you involves a lot. X squared minus 1 is what? Difference of two squares. So it can be written as x plus 1, x minus 1. Okay, so let's do that one for this part. Okay, don't worry about how it has appeared. System is giving us some issue, but don't worry. The most important is to get our understanding. So dk over dx plus dz over dx is now equal to this, and then after apply difference of two square, here is 1 plus x, and this one is 1 minus x. Cool. Now the whole of this and then the whole of this. What can we do? Factorization. Factorization. That is, here we are having 1 plus x, here we are having another 1 plus x. That one can come out, right? And when we come here, when we bring that one out, here is going to be left with 4x squared tangent inverse of square root of x plus this one will give us square root of x into bracket 1 minus x, 1 minus what? X bracket close. Okay, now after factorization, this is what we have gotten, and looking at it, this and this are the same, so this and this will cancel out and it will left with 4x. So that is how come this next step we had this. So after doing the cancellation, this one is now equal to 4x squared tangent inverse of square root of x plus square root of x into bracket 1 minus x divided by what? 4x. After adding a and b, have you seen what we have gotten? Provided if we have put all of them together, it could have given another, could have worsened our issue. It could even discourage you from what? Solving. But when you do it this way, make you feel good. Okay, system is giving us some issue, but you don't worry. Though it has appeared like this, but you don't worry. The most important thing is to get the understanding. I hope you are clear from this part. Okay, so the answer to the addition of a and b is what? This one. Now let's move on to the other one. Okay. So here you're going to put c and d together. So it seems my technicians, they are working on it. It seems getting back, but no problem whether I get back or not. Let's focus on our lesson. That is the most important thing. So dt over ds plus dp over ds equal to square root of x divided by 4x minus square root of x divided by 4. one is C and then one is what? D. Though we are adding, but answer to one of them was what? Negative, negative, negative. Okay, here, what is the LCM? The LCM is just 4x. 4 is here and s. So it's just 4x. Okay, the LCM is 4x. Okay, so if the LCM is 4x, here 4, this one divided by this one will give us what? The square root of x. And then here 4x divided by 4 will give us what? X. X multiplied by this one will give us what? That will give us what? X square root of what? X. Hey, another thing has also appeared here. I said this one, it entails a lot, so you just take your time. It is going to get it, and I hope at the end of the day, yeah, you feel so good. It wasn't easy, but don't let it scare you. Don't let it scare you. That's how math is. Math is. Those who will help us, get formulas for various other aspects. They did go through a lot. Math is sometimes easy, but sometimes not all that easy. And it happens that way when you don't get your answers. Okay, so let's continue. What are you going to do? Now let's factorize this numerator. Square root is here, square root is here. So let's bring square root outside. If you don't do all these things, you will never get your answer. You don't know what the marking scheme is going to state in terms of awarding marks. So you have to be doing all these things in petty ways like this, and then you'll be getting your hot answers. So square root of x into bracket 1 minus what? X all over divided by what? 4x. Hey, the other part we had square root of x into bracket x minus 1. But here we have gotten 1 minus x. That is why I've been telling you have to be doing these computations. Who knows? These petty workings, now is reflecting something. It is telling us that maybe we might be getting some similarity which can be what? Taken away. You see? Good. So here, to make this one look like the other part, 1 minus x, what are you going to do? We can rewrite this one by making this square root what? Negative. When we make it negative, it will look like the same thing. It will appear the same thing as what? This one, or maybe that. Okay, the moment we negate the square root of x, the inside here will change, but when we open it, it will be the same thing as what? This one. Let's find out. You see, minus square root of x into bracket x. You see, I told you that the moment we negate it, the inside own will also what? Change, or what is in the bracket will what? Change. You see, here it was 1 minus x. When we open this one, it's just like what? This one. But let's open this one if it will give us the same thing as this or that. Let's open it. This one, this negative sign here means we have multiplied this one by what? Negative 1. And when we do that, here will be what? Plus, and this one will be minus. So that is what is signifying the multiplication, or what is reflecting or indicating the multiplication of what? This by negative what? 1. Okay, so now let's open it and let's see if we get something like this one or this. Now minus square root of x times this one will give us what? Is it not the same thing as this? Minus square root of x times minus 1 will give us what? Is it not the same thing as this one? Yeah, it's the same thing, but just that we rewrite it to help us what? Solve our problem. Okay, so the answer to addition of c and d is what? Minus square root of x into bracket x minus 1 divided by 4x divided by what? 4x. Now that we know the answer to addition of both of them, that is a and b and then c and d, now let's move on to the final part, that is the derivative of y, the dy over what? Dx. dy over what dx. So we are going to, with dy over dx, we're just going to put answer to the a and b and then c and d together. We're not just going to do a plus b plus c plus. That one could have confused us. Okay, and doing this way has helped us, know how to, go by. Writing it this way tells us that the other part we saw something of this form, but it was rather this. So we choose to rewrite this one to get the same thing as that, so that when we get there, it can be eliminated. What do you think? Yeah. So let's continue. So add, instead of a plus b, I'm writing this one so that you know what I'm referring to. So add dk over dx plus dz over what dx. When I say this one, you know the answer to this one, you also know the answer to this one. So the answer to this and that is what I'm talking about. Okay, so let's add them. But remember, adding them tells us that we have differentiated the original equation, which was y is equal to blah 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 blah. So to show that we have differentiated, we have to what, bring our dy over what the something, or we have to see dy. Okay, so we're gonna get dy over dx is equal to, okay, this one plus this one. Yeah, this one means we are putting it together. So now let's put it together. Though it's like this, but you may guess a negative. When I say put it together, it means plus. But when you are plugging into the equation, you could see that maybe what you are plugging is rather negative. So there's no need for you to bring the operation side, this plus here. I told you this one we had negative square root of s into bracket x minus 1 from the other when we were working on that. Okay, so when we come here, this minus here will just appear like this. It's the same thing as that. Okay, so this is what we had for a and b, and c and d, which is this one. This is what we had. Hey, you see, now we are going to put it together, but you see this one is very 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 simple as compared to when it hasn't been through all this form. Yeah, or when we haven't, add or eliminate some in what bit. You see, the length has what reduced, and now it has become very easy for us. Why is it easy? From the initial computation that we did, we came to know that we were able to reduce the length of some answers. So addition of a and b has just given us what, this one. And can you imagine the whole c and d has just given us what, this simple one here. You see, so putting the two together, it just has given us what, a like fraction. But assuming if you have add the whole a b c d together, I don't think we could have gotten any like fraction. It could have worsened the problem of what adding. It could just confuse some of us. Okay, so here, like fraction, 4x, what are we going to do? We just add, write the denominator, one of the denominators, and then we just add or subtract what, the numerators. So let's do that. Dy over dx is equal to 4x squared tangent inverse of square root of x plus square root of x into bracket x minus 1 minus square root of x into bracket x minus 1. Hey, what are we seeing? What are we seeing? Simple cancellation. By factorizing and doing that algebra aspect, we've gotten some part to be what, eliminated. Let's see this part too. You could see that this one and this one are the same, but this one is negative and this one is positive. So what happens? They go away. That is, this one will cancel out with this one. Very cool, very cool, very cool, very nice. So this will cancel out with this, and it will be left with what? This one divided by what? This. So yeah, after the cancellation, this is what you have gotten. from that very lengthy computation that we undertake. You see what we have gotten, or where we have reached, just very small answer. When we are done doing the cancellation, you could see that the answer that we are going to get is very small, very 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 small. The length is not even, the length is very very small. And look at the how far we have to go to to get that particular answer. Yeah, add some, take away, add this, blah blah blah, just to figure out, just to fix out this simple answer that you are going to get. Okay, so here, what is the final cancellation that we are going to do? 4x squared multiplied by tangent inverse of x, tangent inverse of square root of x divided by 4x. Here is 4x squared and here is 4x. 4 cancel 4, x reduce this one, and what you are going to get, you're going to get dy over dx equal to x tangent inverse of square root of x. Hey, what are we seeing? We have gotten what we integrated the other time. You see, guys, what I've been telling you is true. The moment you integrate a particular, when you integrate something, the answer that you get to that something, when you differentiate it, will definitely give your that you give your something back, provided you don't make any mistake. You see, after all these lengthy workings, that lengthy question that we are supposed to differentiate, or that we are differentiating, this is the answer that the examiner will be looking for. So at the end of the day, if you don't do that computation aspect, you see the number of calculations, you see the calculations, a lot of calculations that we did in order to just fish out this simple thing here. You see, if you don't do it, you will never gonna get your final answer. So guys, the answer to the question that we started differentiating is x multiplied by tangent inverse of square root of what? X, which is the problem we integrated in our previous video. Very cool, very cool, very cool, very cool. Never give up. Maths is fun. Keep on practicing, and one day, who knows, you might become. Yeah, keep on practicing, keep on practicing. Don't say it's length, don't say it's bored. It's never bored, keep on practicing. Okay, so therefore, we are ending there. We are ending the whole derivative of. Just look at how long it is. Just look at, assuming this appears in your exams. Look at the number of minutes that it has took us just to get this answer, or this one. And this one appears in your exams. The lecturer will use about 3 hours, let's say 3 hours, to solve this particular question. It could be only this one, and then he call it a day to solve this particular problem with you. But in exams, you are to solve, let's say, assuming you are to solve the same problem, he will not give you the same 3 hours. He say maybe 2 hours, or 1 hour 45 minutes, or 1 hour. Why, imagine, just look at the calculations that we, just look at the workings that we undertake just to figure out this small answer. The derivative of, sorry, the derivative of the whole of this is this small answer here. The derivative of the whole of this is not the answer to the various answer we had to each and every one of these. No, but the derivative of the whole of this is the answer to this one. The answers we had, the derivative of this and that is the answer to each and every one of them that we are differentiating. So if you want to get the answer for the whole of this, we have to do the computation aspect. So when you are done, don't say you are done. Make sure you do your computation aspect, assuming there are lots involved either in the integration or what, in the differentiation. So guys, the problem here, the answer to the problem here is X multiplied by a tangent inverse of square root of what? X. Very lengthy. That we managed to get our answer at the end of the day. That's cool. Good, good, good. All right, that's it, guys. Please, if you have any question, just leave it in the comment section below and I'll do my possible best to answer you. But maybe if you missed that video, don't worry. If you missed integral of this one, you don't worry. I'll leave a link to that video in the description section below. So if you missed that one or if you didn't see it, maybe you go and click on that link and then you watch. You could see that you're just going to get could see that the answer to this one was this, and now we differentiated this and now we have gotten this one back. All right, that's it. Please, if you like this video, kindly give it a thumbs up, guys. Subscribe and comment. Thanks for watching, and I'll see you in another video.